All right, so to finish up our discussion on the main factors that can affect ecosystems, so far, oops, wrong way again. Oh, this is going super slow. So far, we have looked at, there we go, the following. Good, okay. Deforestation, fire, okay, eutrophic lakes versus oligotrophic lakes. We're skipping the process of eutrophication and we'll go to water pollution to finish up here. So, defined as any physical or chemical change in the surface water or groundwater that can harm living things. Okay. This can be organic solid waste from sewage. Okay, not generally not good for us to be, drinking and bathing in in sewage. Disease-causing organisms from sewage and animal waste from farms, inorganic solids, and dissolved minerals from industry. So these are basically chemical wastes from industry. Biggest ones are going to be heavy metals like mercury and lead. Thermal energy from electrical generation in industry, and organic compounds such as oil, pesticides, detergents. So let's take a look at some of these. So there's three indicators of water quality. Actually, won't take a look at them specifically. One is bacteria. Okay, bacteria. The bacteria we're interested in is coliform bacteria, which is found in the intestines of humans. This is basically E. coli and other such organisms that live in our guts. And if they're in a water system, they indicate the presence of fecal matter in the surface and possibly in the groundwater, which can actually cause sickness, quite a bit of sickness. Okay, it can cause even death in people if it's not treated properly. The second one is dissolved oxygen. And that's all, actually, it's the second one. There's two, really. Okay, dissolved oxygen. So with thermal energy, okay, that we were looking at actually good right here, okay, thermal energy from electrical generation and industry, what happens is that around, let's say, a plant, okay, the warm water is let go into the water system, and warm water doesn't hold as much oxygen. Okay, so it depletes dissolved oxygen in aquatic systems. So oxygen levels drop, and the aquatic systems support fewer organisms as a result of the oxygen dropping, just because warm water has been added into the water body. Okay. Cold water holds more oxygen than warm water, and we know. Okay, so I mean that's just the opposite, and we know about algal blooms already. So this brings us to a discussion of BOD. Okay, which is biological oxygen demand. Okay, and this is a measure of the amount of dissolved oxygen needed by decomposers to break down organic matter in a sample of water. That's the real definition. Okay, and in a BOD test, the water is kept at a constant temperature and it runs for 5 days. Whatever. That's for the IB kids. Then never mind about that. Okay. As the number of organisms in a water body increases, okay, it causes the oxygen demand to increase, right? And this is where we get to algal blooms, right? So if algae are abundant in the water and they're dying, okay, that means that there's more decomposition and there's more demand for oxygen. So more oxygen is used, causing dissolved oxygen levels to decrease. Okay, so as we've been studying eutrophication, which is the real limit of eutrophication causing algal blooms, is a leading cause of low oxygen levels in aquatic systems. Okay, and then we know this story, and I'm not going to go through it with you for the 50th time. Okay, so we're not doing this lab in regular 20, and you are finished the first unit. Good job.